Hello friends, welcome back to our AI/ML series. Myself Arnab Kundu. In my previous video, I discussed decision tree classification model. But a single tree can sometimes overfit data and gives less accurate predictions. So today I will explore random forest classification model which is having a group of decision trees working together. Okay, this process is known as ensemble method. It improves the accuracy by combining result from multiple decision trees, right? So go to the computer screen. I will discuss random forest classification model inside my Google Colab workspace. So let's dive in. Hi friends, today I will discuss random forest classification model is a supervised machine learning algorithm that uses multiple decision trees to give more accurate and stable predictions. So today I will describe random forest classification model in Google Colab step by step, right? So at first we should know more about random forest classification model, right? Random forest classification is an ML model, means machine learning model, in the same family as decision tree classifications, right? But it is not just a single decision tree, because for decision tree classification model is concerned consists only single decision tree, but in random forest classification model it contains multiple or group of decision trees. Okay, that's why it predicts more accurate and stable predictions, right? Decision tree classification uses one tree to make predictions, whereas random forest classifications uses many decision trees known as forest. Forest means a collection of decision trees, right, trained on random subsets of data and features, then combines their predictions via majority voting in classifications. Okay, actually what happened now, in random forest classification each tree gives a prediction. The majority vote becomes the final output or the predicted output, right? For example, a decision tree is one judge deciding a case, and a random forest is a jury of judges each giving their verdict, and final decision is based on the majority vote, right? Now we discuss the key features and real life examples, right? Key features of random forest classifications are better accuracy compared to a single decision tree, okay? Less overfitting because it uses multiple trees, because the majority vote becomes the final output, right? Whatever each and every tree gives a predictions. From these predictions we find out the majority vote and which becomes the final result or final predictions, right? So that's why it is more accurate and stable predictions, right? Easy to use because just like decision tree, also we are using here scikit-learn, means the sklearn module for doing the steps for the random forest classification model is concerned, right? And the real life example is like that. Suppose imagine you want to predict whether a patient has a certain disease based on medical test results, right? If you ask only one doctor, means like a one decision tree, there might be bias, might be. But if you consult 50 doctors like random forest classification model and take the majority opinion, the result is usually more accurate and reliable, and the stable prediction should be, right? So now I will show you all the steps of random forest classification model inside my Google Colab workspace, right? So I have already logged in my Google Colab workspace, and the code is already written into there, and this is the file name we have provided here, random forest classification.ipynb. okay, and the code steps the similar like the previous examples, the decision tree classification model. So for the random forest classification example is concerned, at first we import the libraries, means we import the modules like pandas. Why we are using here? To data manipulation and analysis. Matplotlib and pyplot, this module used for the data visualizations, and scikit-learn, its need. Why? Because to do the tasks of machine learning algorithm is concerned, right? And the second step is load dataset. Now here I am using the iris dataset, which is so much popular and widely used in machine learning program, okay, and it is essentially a flower dataset, right, and it is created by Ronald Fisher in 1936, right, and it has actually 150 samples into 3 different classes, or means 3 different species of flowers. One is the Setosa, other is versicolor, other is virginica. Okay, here Setosa defined as a class 0, versicolor defined as a class 1, and the virginica is defined as a class 2, right? And the inputs are here, actually the 4 inputs are there. One is the sepal length, sepal width, petal length, petal width. Sepal and petal are the component of the flower, and the outputs will come from this, out of these 3 classes. On that basis, whatever the predictions done by the model. Okay, so this iris dataset is used here for doing this random forest classification model is concerned. So that's why we load this iris dataset at first. Then we do to create the data frame object. So we are sending some arguments here, and then also we create a series. One is a data frame which is in a 2 dimension, and the series is a 1 dimension. So x, y, in that way we are already defined here. And then we split the data. We already know when we split, we need the function train underscore test underscore split, and x underscore train and y underscore train are using for the training purpose, and x underscore test and y underscore test used for the testing purpose. X underscore train for the input features for training, and y underscore train predicted output for the training. X underscore test is the unseen inputs for the testing, and y underscore test predicted output of the testing. And here we are sending this capital X and Y for input features and the predicted value. We put test underscore size equal to 0.2, means we have split the data in training and testing in 80-20 respectively, this format. And random underscore state equal to 42, already told that in my previous video. Ensure the same split for the data set is concerned, means ensure the productivity of the result. Okay, and we use this model random forest classifier and send this to argument. One is n underscore estimated equal to 100, means we have trained the model with 100 decision trees, 100, right? And also we said here random underscore state equal to 42. We create the random forest model here, and then we train the model with the rf underscore model dot fit, okay, with these 2 different arguments, and then make predictions on some unseen data which is present in the iris dataset but not given in the training dataset. So x underscore test is the input features, unseen input features, and on that basis it will predict. And after that we evaluate the model using 3 different functions: accuracy underscore score, confusion underscore matrix, and classification underscore report. And we are evaluate the model using this actual predicted output for the unseen data, and whatever we get as a predicted value, means we are evaluate the model in that respect, right? And then we predict for a new sample, totally new sample which is not present within this iris data set, and we send what, some numerical value for the measurement is actually the numerical measurement for the sepal length, sepal width, petal length, and petal width. In that way the data frame is created already, and the iris data set containing that order the sepal length, sepal width, petal length, and petal width. This is the numeric value, and for the measurement, and we already know that the sepal and the petal are the components of the flower, and it's given in a centimeter. The measurement unit is a centimeter, okay, and it's a continuous value. So that's why given some floating point value into there, okay. And now we predict on that particular new sample, whatever we provide, on that basis it will predict the output, which class it belongs, Setosa, versicolor, or virginica, okay. And then we visualize our decision tree, and then also we find out the feature important bar chart. We visualize the single tree, because we have visualized a single tree inside the forest, because all trees not possible to visualize, right? So that's why we need only the single tree. From there we can predict how the random forest model works, right? So that's why we just provide a single tree from there, and also we give the another visualized part, which is an feature important bar chart, means which features are most important for classification decision, right? So now if we run this code, just press this button, just it will take some times to generate the result, and then we conclude what will be the result and what will be the predictions. It will now execute. Yes, accuracy is 1.0, means the model is perfectly work, okay? And then it provide the confusion matrix values in that way. Actually what happened, this confusion matrix in this row means these are the actual level, this is actual level 0, actual level 1, actual level 2, and these are the predicted level 0, predicted level 1 and predicted level 2. So this position 10 means 10 samples from the class 0 are correctly predicted as class 0, and this position 9 means 9 samples from the class 1 are correctly predicted as class 1, and 11 samples from class 2 are correctly predicted as class 2. Means 10 samples from the Setosa class or Setosa species, 9 samples from the Versicolor species, and 11 samples from the Virginica species or classes is concerned, okay? So that means confusion matrix shows perfectly classified. In confusion matrix, others at 0 means no misclassifications happened, right? And this is the classification report, also give the precision, recall and F1 score and the support. These cases all are the one. These are the different samples are classified in different classes concerned, and also put the accuracy and macro average and weighted average, and all predict perfectly. They are perfectly predicted and the stable prediction they are given, okay? And the accuracy is near about 100, right? And the predicted class is Setosa according to this whatever the input features were given here. For the new sample is concerned, the sepal length, sepal width, petal length and petal width, it predicts that the class is Setosa, okay? And now this is the visualization, this is the tree view, the visualization of the tree for one tree inside the forest. Forest means already told the collection of decision trees. So in that way each and every decision tree is generated, and from there the majority vote becomes the final output, okay? And this is feature importance bar chart, which shows which features are most important for classification decisions, right? So they are given petal width and petal length, and the most important features are petal width and petal length according to this diagram it shows into there, okay? I hope you have understood today's video. Today's video is very simple, and in this video we discuss the random forest classification model. In random forest classification model, each tree makes a class predictions, right? And the final class is decided by the majority vote. So that's why in that way it's predict. And what happened, we already told 100 decision tree is trained within this model, and the model name is what? It's already given into there. The model name is random forest classifier. Using 100 trees, the model is trained. So in that case, this is the visualization part, one decision tree from the forest. So this is the first tree. So if we put here 1, so it will put the second tree. Just see, this is the first tree is concerned, and if you again run it, so it will show the second tree. Just see, the tree is different from the first one. So in that way 0, 1, 2, in that way 99 up to that, the different trees are there. Using that the model is trained. I hope you have understood today's video. If you have some doubts for today's video is concerned, just type in the comment section. I will try to solve this problem. Those who are still not subscribed my channel, please subscribe it. Keep watching Technical Arcade, because more AIML videos will come very soon. So today up to this. Thank you and bye bye.